Okay, so this is the first lesson for math, Introduction to Geometry. All right, so let's begin with the lesson. All right, so here are some basics for the SAT. And so the geometric notation, we use to describe lines, arrays, points, angles, etc. And geometric notation is sometimes not covered in high school geometry, so you may not have seen this before. But most of the high schools already know about this, so you should be fine. So some examples of geometric notation. If there's a line over AB, that means that the line goes through points A and B and continues on to infinity. So it goes on an infinite number all the way, like without stop. So dotted lines over AB means that there's a line segment with endpoints AB. So the difference between the first and the second lines is that the first line goes to infinity, but the second line has endpoints, which means that the line ends at these 2 points. And now, whenever you see like an arrow over AB, it means that there is an array with endpoint A that goes through B and then stretches on to infinity. So array is a combination of a line segment and a line. We have an endpoint, and it goes on to infinity. It's pretty simple. When it says an M is less than sign ABC, it means that the measure of angle ABC with the middle letter, in this case being B, being an angle, or the vertex, and point A on one leg and C on the other. And we'll see that later in the presentation. So a triangle ABC means the triangle ABC with vertices at A, B, and C. And if there's like another shape, like a quadrilateral, it means quadrilateral ABCD with vertices at A, B, C, and D. Now AB with basically an upside down T, BC, means that these two line segments are perpendicular to one another. So it means they create two 90-degree angles. And now points and lines. So a line is created by connecting any 2 points. So we can say this is sort of like a line segment where it connects any 2 points. Between any 2 points on a line, there is a midpoint that is halfway between the 2 points. So a midpoint is basically the halfway point in between 2 points. So half, basically. Any 3 or more points may or may not fall on the same line. If they do, then we can say that the points are collinear. So that means if we have 3 points on one line, so if we have like points A, B, C, D, for example, maybe similar to that. So, all right. So angles. To measure how wide or big an angle is, we use a unit called degrees. So this less than sign, once again, this basically means an angle is a 45-degree angle. If it's like a perpendicular, basically half of this is a 90 degrees, also called a right angle, which is very important for triangles. And that's the straight line is 180 degrees, which is the same thing as a straight line. All right. Supplementary angles are two angles that add up to 180 degrees. Complementary angles are two angles that add up to 90 degrees. So here, there are some tactics that I like to use. We have supplementary. And a simple way to know how this adds up to 180 is that we can make it look a little something like 180 degrees at the very beginning. And so we can also do the same thing with complementary as well. So if we have complementary, so it's kind of a bad example, apologize, but the beginning, we can just draw a line and it looks like a 90 degrees in the beginning. So now we move on to the next one. When two lines intersect, angles opposite of each other are equal in measure. So these are called vertical angles. And vertical angles are basically always the same no matter what, when they intersect. So like, for example, these two angles right here will also be equal. All right. Now I have triangles. So triangles, the sum of the three angle measures in any triangle is 180 degrees. So it's pretty straightforward. If you add up all the angles inside a triangle, it's 180 degrees. In any triangle, the longest side is always opposite of the biggest angle, and the shortest side is always opposite of the smallest angle.
Yeah.
In an equilateral triangle, all the sides are the same length and all the angles are 60 degrees. So here's an example of an equilateral triangle. From here, we can see that all the sides are the same length and all the angles are 60 degrees right here. So we can see on the side, A equals B equals C equals 60 degrees. In an isosceles triangle, two of the three sides are the same length as to each other, and two of the three angles are the same measure as each other. So we can see angle C, A equals C, A equals C. So for obvious reasons, B wouldn't be equal since it's just different length than these two. And now another triangle is our right triangle, which is 190-degree angle right here, a right angle. As one of its three angles. The right angle is represented with the square in the corner it is in. So we can see that A also 90 degrees. And now some special triangles that are helpful to know are a 45, 45, 90 angle triangle with the sides of 1, 1, with a side length of 1, 1, and then a square root of 2. You can also do this. You don't really need to memorize this. You can use math basically to solve it with the Pythagorean theorem. But knowing this is also very helpful. And so in another triangle, we have a 30, 60, 90 triangle. In a 30, 60, 90 triangle, we have 1, square root of 3, and 2, which you can also use with this math, this Pythagorean theorem. And now in the Pythagorean theorem, if you take the two lengths of the shorter sides or legs and square them, and then add those two squares together, the resulting amount is the square of the length of the longest side or the hypotenuse. So the longest side in a right triangle is always the hypotenuse. So an example would be, I guess above, we have 1 squared plus square root of 3 squared is 4. And then we just square root 4 and we get 2. So some more things as a Pythagorean triple. So it's a set of 3 numbers that can be side lengths of the sides of a right triangle. If you know 2 of the lengths, you will be able to know the third length using this trick. So this is basically the same. It's also very helpful to know. So we have the 3, 4, 5 triangle. It shaves off a couple seconds to find a hypotenuse, but anything is. You can also just use a Pythagorean theorem. The same thing with the rest. You can have to memorize them, or you can just use the Pythagorean theorem on the test. When we multiply each number in a Pythagorean triple by the same number, we get another Pythagorean triple. So, for example, since we know that 3, 4, 5 is a Pythagorean triple, then we also know that 6, 8, 10 is a Pythagorean triple, because 6, 8, 10 is what we get when we multiply 3, 4, 5 by 2. So 2 multiplied by 3, 4, 5 creates another Pythagorean triple, 6, 8, and 10. Okay. So two triangles are similar triangles if they have all the same angle measurements for each corresponding angle. It's pretty self-explanatory. If the angles inside a triangle, if two triangles are the same, then the triangles can be considered similar. The formula for the area of a right triangle is the base times the height divided by 2. And it's provided in the front of every SAT math section. So in the front of every SAT math section, you have a list of formulas, and you also have these triangles, the special triangles here, the 45, 45, 90, and the 30, 60, 90. In every triangle, the length of each side must be less than the sum of the length of the other sides. So if you look in the above, we have 5, 12, and 13. So if you add up 5 and 12, it has to be greater than 13, like 17. So 5 plus 12, since it's 17, it's greater than 13, which is exactly why it works. Alright. And now quadrilaterals. Parallelograms. A parallelogram is a four-sided figure in which both pairs of opposite sides are parallel to each other. In a parallelogram, opposite angles are equal to each other, and the measure of all the angles added up together equal 360 degrees. Okay, so if we draw a parallelogram, And then the interior angles add up to 360, and the opposite angles have equal measurements. Now, rectangles are special parallelograms that have 90-degree angles. So they're similar to a square, in which they all have 90 degrees. But in a rectangle, if you know the lengths of the side, then you can always figure out the length of one corner to the opposite corner using the Pythagorean theorem. So when you cut this rectangle by the diagonal, you get two triangles, which also is why the formula base times height divided by 2 works. So an example, in a rectangle here, all angles are the right angles, and we can use the Pythagorean theorem to determine the diagonal using the length and the width. So since this is the length and width, and we're trying to solve for this. So by using Pythagorean theorem, we get the length squared plus w squared equals w squared. All right. So here are some geometric calculations. The perimeter and angles. So the perimeter is the sum of the length of its sides. The perimeter of a circle is called the circumference. So this is the circumference right here. This whole circle around the outside. To find the perimeter of a non-circular object, just add up the length of all the sides. So if it's non-circular, like a hexagram, for example, just add up the side lengths, and it should be fine. So the formula for the circumference is 2 times pi times r, which is the radius of the circle, or pi times d, which is diameter of the whole circle. And always remember that the radius is always half of the diameter. The sum of the angle measurements of any polygon can be determined with a simple formula, where s is the number of sides. The sum of the angle measurement is s minus 2 times 180. So the s obviously is the number of sides, the number of side lengths in a polygon, and we always subtract 2 and then multiply by 180. So for example, a square has 4 sides, so s is 4. So the sum of its angle measurements can be given by 4 minus 2 times 180. And when you do the math, it ends up being 360 degrees, which is why a square has 360 degrees. So if you want to solve complicated geometric problems, like want to find the area of a hexagon, it's not optimal to try to find the area, like the whole time, memorize a formula for the hexagon. Rather, split the shape of the hexagon into like triangles, like here, into 6 different triangles. It also works with any other polygon as well. All right. So the area of a two-dimensional figure is the amount of space that the figure covers. So in the hexagon circle shown above, the area would be everything that's inside as bounded by the side lengths. For example, in the hexagon, everything inside the bolt. All the area formulas you need for the SAT is in the beginning of every math section. So as mentioned above, in every math section, you'll be given the formulas for everything. Formula for area, perimeter, and also like these special triangles, 45, 45, 90, and 30, 60, 90 triangles. So as here mentioned here, it is recommended to remember them because you will be able to save more time if you do not have to flip between pages for equations. So try to memorize all the equations as much as you possibly can. It saves a lot of time. And just for your edification, the area of a rectangle is the length times the width, and the area of a circle, which isn't given above, is pi times the radius, which sounds like the circumference, but we multiply it by the radius again. So we do pi times the radius again, and that is the area of a circle. And so to review, we start from the basics. Geometric notation. Most of the geometric notation that you need to know is pretty common sense. For example, a line segment, and the measure of angle ABC. And so geometric notation shouldn't really take that long to memorize. For example, like a triangle ABC, this is a triangle ABC. And some rules that are very important to know is the fact that vertical angles are equal to each other because they're opposite, and the supplementary angles are 180, and complementary is 890. Triangles, there are multiple types of triangles: equilateral, isosceles, and right. And the angle measurements are always the same, or not always the same, but the type of triangles are always have the same angle measurements. And if they have the same angle measurements, then they're called similar triangles. And the Pythagorean theorem, this is one of the most important concepts of geometry. When you a squared plus b squared equals c squared, it's probably the most important thing, and very something that you should look to memorize. So triangles, the Pythagorean triple. So once again, it saves a lot of time, but you can also just use math. You can also use the Pythagorean theorem, for example, to solve for the hypotenuse or for any side length in general. In quadrilaterals, we have parallelograms. They're four-sided parallel. So for example, a rectangle would be a parallelogram because all sides are parallel. So, and also to find, so as you can see from the area, if you cut this in half by the diagonal, you get the area would be width times the length divided by 2, because you cut the rectangle in 2. So that's why the formula comes from. Now, geometric calculations. The perimeter is the sum of all the sides, and the area of basically a perimeter of a circle, quote unquote perimeter, is a circumference, which formula is given by 2 times pi times the radius, which is half the length of the circle. So, and also the formula for angle measurements is s minus 2 times 180. And so, for example, given as like a square, we have a side length, plug it in, and then we'll solve it, and then you get 360. So if you're stuck on a question with a complicated geometric figure like a hexagon or an octagon or a dodecagon, then try to split up the family shape into squares, triangles, circles. Well, preferably not circles because they have no straight edges. So just triangles or squares. And finally, the area is how much space a figure takes up. How much space is limited within the side lengths. And all the formulas are going to be needed, are given at the very beginning of each section for the SAT. So, but it's highly recommended that you memorize the formulas. And so the area of a circle is pi r squared, which is pi times the radius times the radius. And the length of a rectangle is the length times the width. So that'll be it for this lesson for geometry. If you have any questions, just type it in chat. That's pretty much it.